In this video, we're going to look at absolute value or modulus. Now, you may see these in a few different formulas, these modulus bars. This means absolute value, so it's only the positive value that we're looking for. So we want to put a number in for x that will make this equal to 5. So this is an easy one. We're going to just look at a simplified version of it, and then we're going to look at it algebraically, which is what we'll need to do in some of these questions. So I can see here that x would have to be equal to 2. 2 plus 3 is 5. What other number could I put in for x to make this 5? Well, you can see it's going to be minus 8. Minus 8 plus 3 is minus 5. And the absolute value is just the plus value, so minus 5 becomes plus 5. But let's look at this algebraically. To get rid of modulus bars, what we do is we square both sides of the equation. So x plus 3 to be squared is equal to 5 squared. And you'll see how we'll form a quadratic and we'll get these two answers here. So x squared plus 6x plus 9 equals 25. So x squared plus 6x, 9 minus 25 is minus 16. So we're going to have x times x. 8 2s are 16 and 8 minus 2 is 6, but we want a plus 6, so plus 8 minus 2. So x is equal to 2 or minus 8, the two numbers that we got up above. So this is how we simplify modular equations. Now we'd be asked to graph them as well, but let's simplify a few more before graphing them. So in a question like this, solve for x, the absolute value of x plus 1 minus the absolute value of x minus 5 is equal to 0. You may be able to solve this quite easily just by looking at it, but let's use an algebraic method here. So if we say x plus 1, we get rid of the absolute value bars, equals x minus 5, and square both of them. This is the algebraic method. So we could use the modular bars first and then get rid of them and square them on the second line, but we know that we have to square these modular equations. So we're going to get x squared plus 2x plus 1 is equal to x squared minus 10x plus 25. Straight away we can cancel our x squareds, and if I bring the 10x to the left, we're going to have 12x, and if I bring to the 1 to the right, we're going to have 24. So x is equal to 2. So if we want to graph these, if we take each individual one, I'll do y is equal to, well, we'll take each individual one as a function. Y is equal to x plus 1. So I'm going to start with some x values here. I'm going to start at minus 4 for x, and then I'm going to get an answer for y. So if I put minus 4 in for x, I get minus 4 plus 1 is minus 3. So the absolute value of that is 3. If I put minus 3 in, you're going to get minus 3 plus 1 is minus 2. So 2. So you can see the pattern now. It's just gone down. Minus 1, 0, 1, 1, 2. What have I skipped here? Put in 0 as well. 0, 1, and then 1, 2. So just take your time with them. 1, 2, and then I'll do 2, 3 as well. 2 and 3. So you can see the patterns here. So we're only looking above the x-axis when we graph modular equations. So if I put these values in, minus 4 is 3. Minus 3 is 2. I'm going to go minus 1 is 0, so I don't have to put all the points in. 0 is 1. So you can see what happens here. It comes down towards the x-axis and it bounces up off the x-axis, either coming from left to right or right to left. I'll just do one more point here, and I'll pick 2, 3. So graphing this, you guys are going to use a ruler. And I'll try use just freehand, but it's a little bit shaky. So this is the graph of the modular equation y is equal to x plus 1. So if I do beside it, y is equal to the absolute value of x minus 5. And I do my same values for x, although my values will shift. So we'll see why maybe taking the same values is not the right thing to do. So if I put minus 4 in, I'm going to get minus 9, which will give me a plus 9. Minus 3, I'm going to get minus 8, which will give me a plus 8. So minus 2, 7, minus 1, 6, 0, 5, So I don't need all of these values, but I'm just showing you them. 1 is going to be 1 minus 5, which is 4. And you can see the pattern here. 2, 3, 3, 2, 2, 1. Not 2, 4. 4, 1. And then 5 minus 5 is 0, so 5, 0. So you can see this point here. And then we're going to have it going to the left and to the right. So we didn't need all these values over at this side of the equation. So we want to take the number that's in the equation, the 5, and we want to take some values either side of it. Same with the 1. We want to take a 1 and we want to take values either side of 1 or minus 1. In this case, we change the sign. So let me try and graph this. So a couple of attempts to draw it. So going forward, what we're going to do is we're going to take the point that where it crosses the x-axis, the point that where it crosses the y-axis, and we're going to match off then, in this case, to the right of 5, where it crosses the y-axis. So you can see if we draw a straight line across here, we get to the number 10 because we have to go back 5 and across 5. So you can see where these cross. They cross at the point. From our table, we have a 2, 3, and we have a 2, 3, which is this point here. We're asked to solve for x. So in this case, x is equal to 2 here, but it is the point 2, 3. And if we put a 2 back in here, we're going to get 2 plus 1 is 3, and we're going to get 2 minus 5 is minus 3. And the absolute value of each will be 3. So that's solving it graphically. Now there is another way, and it's based on the midpoint of the roots on a quadratic equation. So let me just change the color of the pen again. So here's where the red y is equal to x plus 1 crosses, and here's where the y crosses. Now the midpoint of the roots will give me the max or min, and that's actually the same as what we do here. So it's the distance from this point to, we're going to go 1, 2, 3, 1, 2, 3. So doing it another method is to find the midpoints where they both touch the x-axis. The midpoint of each will give us another way of solving these modular equations. So practice questions like this before moving on. So look at this question. Solve for x. 1 is less than the absolute value of x minus 2, which is less than or equal to 3. Now there's a nice quick algebraic way of doing it, but I want you to pause the video, graph y is equal to 1, y is equal to 3, and the absolute value of x minus 2. And we look at the solutions when you have that done. And then we look at the easy algebraic way to do this question. Okay, so graphing y is equal to 1 and y is equal to 3 first, with a steady hand. Or a non-steady hand. It's a bit buckety. Do a better one than that. Better. Y is equal to 3. Okay, straightish. Okay, so the easiest way to do the modular ones, let's find out where it crosses the axis first. So to make y equal to 0, we would have to have x is equal to 2. So this is then, I'll actually change colors, I'll do it in red. So this is where it crosses the x-axis. So what about where it crosses the y-axis? Well, it crosses the y-axis when x is equal to 0. So if this is 0, we get a minus 2, and the absolute value of that is 2. You can see here I've had to go 2 to the left, and I've gone up 2. So if I want the other part, the mirror image of that is 2 to the right and up 2, which you get me to the point 4, 2. So just finishing off the graph of the modular equation x minus 2. It crosses when? Does it cross this line? Y is equal to 3. Well, when is this equation going to give me a 3. It's going to give me a -1, -2. So approximately here, I'm slightly off with my graph. That will be the point -1, 3. When is it going to give me a value of 5? Or sorry, a value of 3 when y is equal to 3. So 5 minus 2 will be 3. So it's going to be a 5 here. So this is the point 5 on the x, 3 on the y. So we look at our overall solution. We're asked, when is this modular equation between these two lines? Now we have less than or equal to, it's a bit like the real numbers when we're coloring in the number line. It's less than or equal to 3. And I'm just going to put a circle around this and not color it in these two values here. So we're asked, when is this modular equation between these two values or these two y values? So on the left hand side here, so if I'm looking at this point and this point, my x values are between 1 and -1, and it's less than or equal to -1 part, because that's on the line y is equal to 3. And on the right hand side, I have 2 parts to it because this solution is not part of what we're looking for. And then I have my x value is going to be between 3 and 5. And the 5 is on the line y is equal to 3, so that's the less than or equal to part. So this is the end of the modular equation lesson. We're going to go and look at another type of graphing in the next lesson.